Hey guys, welcome back. So what we're looking at today is lesson 10, finding the value of a relationship. So 6.10. So let's go ahead and jump right in. So here we're modeling real world problems with triangles. So for each story presented below, sketch a picture of the situation and label as much of the picture as possible. No need to answer the question or find the missing values. Simply represent the situation with a sketch. So we are not solving on these. That's the beautiful thing here. We don't have to solve. So I'm going to do number 3 with you. Abby is standing at the top of a very tall skyscraper and looking through a telescope at the scenery all around her. The angle of decline on the telescope says 35 degrees, and Abby knows she is 30 floors up, and each floor is 15 feet tall. How far from the base of the building is the object that Abby is looking at? So we know we need to figure out how high up she is, first of all. So we know she's 30 floors, and each floor is 15 feet. So 30 times 15 is 450 feet. So we've got this height of 450 feet. Now, she's looking off this direction, and it's at an angle of 35. So from there down, it's an angle of 35 degrees. Now, what we don't know is how far away the object is that she's looking at. So there's our x right there. This would be a right angle. We would be able to solve this using trigonometric ratios. So this is what you guys are looking at doing. So you're just drawing the pictures. You don't have to try and solve for x in any one of these 3 problems. Now here, we are going to solve for x. We're going to solve for the missing value. So for each triangle, we're going to find the missing angles and sides. So trig is your keyword for this lesson, trig, because we are using trigonometric ratios to solve. So for number 4, we want to find the missing angle measures and side measures. So we know that angle C is the 90 degrees, but that doesn't help us in finding the angle measures. Now, finding AC, this side here, we can use the Pythagorean theorem. So we have 4 squared plus b squared equals 10 squared. So we have 16 plus b squared equals 100. Subtract the 16 from 100, so b squared equals 100 minus 16, which will give us 84. And we take the square root. And when we take the square root of 84, we get approximately 9.16. So that is our side length. You can also leave it as the square root of 84. That would be perfectly acceptable. Now, for finding our angle measures for angle A. So if we are looking for angle A here, we have opposite and hypotenuse. So which of our trig ratios represents opposite and hypotenuse? Well, that would be sine. Sine is opposite over hypotenuse. So I'm going to come up here so I have space to write. We're going to have sine of x equals, opposite is 4 over 10. Now, in order to take and solve this, we take what's known as the inverse sine. So for these, you will need a calculator. There's no other way around this. If you don't, if you have an iPhone, turn your calculator to the side and you'll get the extended calculator and you can use that if you have any other phone. And I will tell you, on an iPhone, you have to hit the second button to get the inverse sign, the inverse ones. If you have another kind of smartphone, see if it has an extended calculator. If not, you can go to Google and type in what is the inverse sine of 4/10, and it's going to give you the answer. It's going to give you what that angle measure is. And that's perfectly fine because I understand you may not have a calculator or be able to access it on your phone. So taking the inverse sine of x gets the x by itself. So we have to do the same thing to this side. So we have x equals the inverse sine of 4/10 is going to give us 23.58 degrees. So that is our angle A, is 23.58 degrees. Now, there's 2 different ways that we could solve for angle B. One, take 180 minus 90 minus 23.58. That'll get you angle B. The other way is to use our trig ratios and solve. So looking at B, we've got adjacent and hypotenuse. We'd use cosine and then the inverse cosine. I'm going to use 180 minus 90 minus 23.58, which is going to give us 66.42. So angle B is 66.42 degrees. So you're going to do the same thing on 5, 6, and 7. So you only use the inverse sign when you're trying to solve for an angle measure. When you are trying to solve for a side measure, it's a little bit different. So you just use the actual sign value. So you do using that degree sign of that degree, and then you'd either divide or multiply by one of your values to take and solve. So like on 5 here, if we were trying to solve for, let's say, BC, I'm going to set this one up just so you can see it. We would have opposite over adjacent, so it'd be a tangent. So we'd have tangent 20 equals, let me erase this trig here. Tangent 20 equals opposite 30 over x, because we don't know what that side is. Now, in order to solve this, well, we'd multiply by x, that would cancel, so we'd have x tangent 20 equals 30. We still have the variable with something. Oops, not divide by x. We divide by tangent 20. Divide by tangent 20. That cancels, so we'd have x equals 30 over tangent 20. Now, same thing. In a calculator, you're going to plug all of this in. So you're going to take 30 divided by tangent of 20. So having an actual calculator here is very, very helpful. You could do it on your phones. You just have to be super careful about order when you do it on your phone. If you do it through the computer, type in 30 divided by the tangent of 20, and then you should be able to get your answer. And when we do that, you are going to end up with 82.42. So that's what it looks like when we're taking and doing this. So you're just going to rearrange to solve. So sometimes if your variable is in the denominator, you're going to end up dividing by whatever the trig ratio is with its degree. If the variable is in the numerator, you're going to multiply by whatever the other side measure is to your trig ratio, okay? All right. And this last part down here. Use the given right triangle to identify the trigonometric ratios and angles where possible. So sine of A, we're looking at opposite over hypotenuse. The hypotenuse is going to be the square root of 2, because 1 squared plus 1 squared is going to give us 2 equals c squared. So it's a square root of 2. So 1 over root 2. Sine of B, opposite over hypotenuse, also 1 over root 2. Cosine of A will be 1 over root 2, so we'll cosine of B. Tangent of A is opposite over adjacent, so 1 over 1, or 1. Tangent of B will be the same thing. And then the measures of A and B, because this is an isosceles triangle, both of them will be 45 degrees. All right, if you guys have any questions, feel free to ask. Have a great day.